Good evening, everyone. I'm Ellie Breakwell, the APM Branch's coordinator, and thank you for joining us today at this APM Northern Ireland Branch webinar. Please be aware that this webinar is being recorded and you're in listen-only mode. There will be some interactive elements to today's webinar, so please have your phone or another web browser open and ready to go to menti.com and use the code 7092701. This will also be displayed on the screen with each question. Today we are joined by Alan Reddick, Karol McCusker and Gerard McColgan. If you have any questions for our presenters, you can submit these via your control panel, and time permitting, Robert Smith will read those out to speakers at the end of the presentation. Thank you again for joining us today, and without further ado, it gives me a great pleasure to hand over to you, Alan.
Okay, thank you. Right, first of all, I welcome everyone, and thanks very much for giving up your time to join us tonight. Basically, as Ellie said, there's three speakers, so I'll be giving a very short overview on behalf of the client, and the client who I work for is DFI Roads and Rivers. And then I'll hand over to Karol McCusker from ACOM, who will give a more detailed talk on the design of the scheme, and then finally to Gerard McColgan, who will talk about the actual construction, which is ongoing at the moment. Okay, next slide, Gerard, please. Right, okay. Basically, Newcastle, which you can see on the screen there, has a history of flooding. It's not just the Shimna River. In the past, a lot of the flooding tended to come from the Burren River. So there's actually four rivers in the very close vicinity. There's the Shimna River, which you can see quite clearly in the centre of the scheme, and just further down, it's maybe not just as clear. I can't really use a pointer, but you'll find from the north, halfway down the middle, that the Burren River actually flows into the Shimna, and the Tully-Brannigan River flows into the Shimna from the other side. And the flow in what's like a boating lake, you'll see sort of a bigger sort of blue area down near the coast. And there's also another catchment which was involved in the Burren scheme, which I was involved with a long time ago, and that's the Leitrim River. So basically, 2030, there's a history of flooding 40, 50 years ago, but about 20 years ago we were involved in a local consultant, RPS, in Belfast, who looked at a whole lot of individual sort of outline studies, not detailed studies, but just to look at the flood mechanisms in around Newcastle. And what actually happened was that at the time, the Burren scheme was found to be the most problematic, and the river which the floodplain flooded an awful lot of houses. So basically, the Burren scheme was taken forward by RPS, feasibility, and then on site. The site work started about 2005 and 2006. And the interesting thing is, you're wondering why I'm talking so much about the Burren, but at that time, all the flood records and any of the outline sort of modelling we did didn't seem to direct that there would be a serious flooding and a flooding to a lot of houses on the actual Shimna scheme. So basically, the flood mechanism at the time in the Shimna was not known. So that brings me on to this next slide, which George kindly put up. So what actually happened was this flood came along in August 2008 along Shimna River, and at the time we were actually shocked because of our previous information to the amount of flood damage it actually did. But what actually happened, and I'll show you in a diagram later on, that because of the lie of the land, the flood actually got out of the banks of the Shimna and flooded down the Bransford Avenue Road and into the Shimna Road and Shimna Vale in the centre of the town, and caused flooding to a lot of properties. What actually also happened on the Bransford Avenue Road was that it actually flooded back into the catchment area in the Burren River. And then the embarrassing thing was that we had a scheme up to stop flooding from the Burren with flood walls on either side, and the flooding came from outside that and was unable to get away for a day or two and relied on the black drainage system to get back into the river. So that was a wee bit awkward for us. So basically a lot of flooding because of the lie of the land, and a lot of flooding in the cross catchments in the Burren. Okay, so what we did was, following all that flooding, we did a flood investigation report. And as a result of that, which I've just described, the catastrophic flooding, which was unexpected, we appointed RPS in 2013 to take forward a detailed feasibility study. And just on the other slide, this was backed up years later when, just a couple of years ago, when we were involved with ACOM doing the detailed design, we found out that there was flooding in 2020, which was very similar to the 2008 flooding, and it just augmented the problem and just backed up how serious the flooding would be at high return events. So basically all this slide shows you is basically what I was saying there, but more in the diagrammatic. This is the blow up of that previous slide, and this is the Shimna River in the centre of Newcastle. So some of you will be familiar with, but all this flooding seemed to start around this Bransford Road Bridge, which is called the New Bridge. And what actually happened in the first flood was it broke the banks downstream of the bridge and flew through the council Islands Park. And rather than just getting localised flooding, which you would normally get with a rise in flood levels on a normal river in Spain, it actually had a flood path, and as I said earlier, it flooded everywhere. So it came across these houses at the back of Bransford Avenue, came down the Bransford Avenue Road. I don't think you can see my pointer here, but it came down and flooded across the Bransford Avenue Road Bridge, flooded either side and back into the Burren catchment, which now had the flood defences, which stopped the water getting out until a few days later. And then it got into the town, flooded the other bank of the Burren scheme, and then flooded right down into the centre of the town and into Shimna Road and the Shimna Vale. And the previous flood events were reckoned were around about a Q45, Q50. And this here is the estimated 1% Q100 design flood return period. So maybe the next slide, go on to that, Gerard, thank you. Hello, all right. Okay, this is just the same slide as before. It's actually my last slide, but it actually shows at the 1% there was 312 properties at flood risk. Now, most of these properties tend to be on, as you look at it, the north side of the river, and that's because in the 2008 the flooded into Islands Park, as explained earlier, downstream of the bridge, and then in 2020, which the other two chaps are going to talk about in more detail, there was two of, I think, of the three arches on the upstream face were blocked by heavy debris because obviously there's a lot of forestation in the area. And it actually came up on the Shimna Wood side as well, but a similar flood path, as I say, right down into the town and along Shimna Road and Shimna Vale. So actually there's about 300 houses on the north side which are flooding, and then we estimated the 100-year flood event, there's about another 10, 15, 20 on the left-hand side of the river actually flooding down around the Tullybrannigan River. Okay, so as part of the feasibility study, there was an economic appraisal carried out, and you'll probably be aware of the benefit-cost ratio. So the benefit-cost ratio worked out to be about 1.3, and that was based on an estimated cost for the time of about 4 or 5 million for the scheme, and a flood damage avoidance benefit of around about 8 million. So as we had a scheme, what we did then, we took this on forward and we appointed ACOM to do the detailed design in 2017 and also to carry out, which is very important in our scheme, detailed lands agreements. So that took 2 or 3 years. And then more recently, just to finish my presentation, we carried out an 8 to 12 month procurement process, 2 stages, a quality and a price analysis. And the outcome of that was, and I've been very pleased with them ever since, that Dawson WAM were appointed to carry out the works. So the works was about 12 months and it started about September 2021. We were probably about, obviously Gerard will explain this in more detail, 60-70% of the scheme completed of the 4 walls, and we're more than halfway through it. So that's basically the history of it. So just in a very quick summary, The burn scheme was carried out 2005, 2006. Then the big flood event came in August 2008, and there was a flood investigation report carried out. And as an outcome of that, there was a detailed feasibility which started by RPS in 2013. All the flooding information was backed up again by the more recent flooding in 2020. So we did a feasibility study, highlighted what the expected flooding, the damage to property was. Following the benefit cost ratio, we got a positive cost benefit and were able to proceed with the scheme, a viable option, and appoint ACOM to carry out the detailed design. And then following that, over the last 2 or 3 years, which we worked closely with and carried out a lot of lands agreements and consultations with main stakeholders, we just last year had this procurement appointment stage, and Dawson Wam came out there to carry out the schemes, and we're now halfway through a 12-month construction phase. And that's really it, everyone. So thanks very much for listening to me. And I'll now hand over to my colleague and friend Karol McCusker, who will discuss more the development of the detailed design. Thank you.
Thank you very much, Alan. Yes, hello everyone, I'm Karol McCusker, and I was formerly ACOM. I'm now Government Property Agency, but I was the lead designer in this scheme, and I'm just going to take you through the design considerations. So, Gerard, can maybe get the next slide, please? So, one thing Alan did allude to there is that there was flooding in 2020, a more recent flooding event, and we had hydraulically modelled the entire catchment, and we thought we understood how the flooding behaved. Anyone on the call who is of engineering background or has dealt with hydraulic models will understand that hydraulic models are purely just assumptions on top of assumptions to get you the best possible answer. One thing we noticed that in the 2020 flooding, it didn't have the same behaviours as the previous flooding events due to what people were telling us on the road and what we'd met from our area staff who'd been deployed to resolve the issue. So we undertook some additional modelling, and that, coupled with some recovery of statements from the operational staff who responded, we identified that the new bridge, which is key to all this scheme really, suffered major blockage. And we understood that from the symptomatic response we were getting from the public, saying that the floodwaters rose dramatically, very quickly, all of a sudden. Generally, floodwaters rising very quickly is generally symptomatic of either something failing or something blocking. So with that in mind, we identified that there was a major risk there of blockages occurring again and causing the scheme to be overtopped should it ever be built. So what we did then was we included as part of the scheme was a roughing grill. And a roughing grill, in layman's terms, is large steel circular piles in a riverbed that catches debris. And when we talk about debris in civil engineering, especially in rivers, we talk about trees, cars, mattresses, massive debris, not the usual stuff you see in a smaller screen. So that was installed upstream as part of the scheme. But maybe, Gerard, just go to the next slide, please. So this is basically what we were talking about here when we talk about the 1% annual exceedance probability, or the 1 in a 100-year event. And in order to progress the event, we have to cost it out to cost the damages. And what we do is the cost benefit analysis. So we design a scheme very high level initially to get it costed to see if Treasury would have enough money, if spent, there would be a benefit in the scheme. And there was, with damages of over 8 million, the scheme was less. So there was a benefit there to progress with the scheme. And the plan purely was that you can see the centre of the photograph is New Bridge, and that's in the Bryansford Road. The flooding mechanisms generally are the water comes from left to right. It can't get to New Bridge, so it builds up and crosses over the road, but it also bursts out of bank below New Bridge. So that, in order to solve that problem, what we did was we installed the 4 walls, which are shown as purple lines here, and they were designed to utilise the existing floodplain. Tipperary Wood already flooded to a certain depth, but our plan was to flood Tipperary Wood to a greater depth. That would give the New Bridge time to get the flow through. And then we'd have bridges downstream, which would give the Shimna River downstream more capacity. So this was our typical cross-section for costing purposes. There'll be 2 walls either side, which gives a big blue area in the middle, and that's improving the river's capacity, or giving Mother Nature a hand in order to convey floodwater downstream. And that scheme then we costed out to get cost-benefit analysis with an optimum bias to see would the scheme move forward. Once we began that, we found it was a viable scheme, we then began our more detailed consultations. So the design considerations we identified after we started having consultations. Anyone who knows the Shimna River will know it is in basically the Mournes, and the Mournes itself is a highly environmentally important area for all of Northern Ireland. The river itself also has a significant salmonoid river, and the salmon run it. This local angling club highlighted the importance of trees on the banks. They probably provide more than just shade, as the light pollution is the main purpose of them. And with roads nearby and housing developments encroaching close to the river, the light pollution was to be kept off the river as much as possible. There was also a number of people who'd asked about the issue of pathways through the park, which the scheme would run alongside, and they found that the path surface was somewhat irregular. The paths weren't exactly beneficial for all users. And then we also identified that there was improvements to the existing playground and protection to significant trees in the park. There was a number of trees in the actual park that both the children, local children and families and all related closely to, and there were trees that we wanted to maintain as part of the scheme, so we had to look at how we develop our scheme around them. We also wanted to maintain access for council vehicles as they had to maintain the park, and we also noticed that part of the park path opened out on the Bryansford Road. And we were concerned that with the number of people, if we were improving a park area, the numbers would improve. The numbers would improve, there'd be more risk of people entering onto the road in an uncontrolled manner. Now, you can see by these points that although we started off with a flood alleviation scheme, and the Department for Infrastructure Rivers' primary goal is to alleviate flood risk in Northern Ireland, generally civil engineering schemes and flood alleviation schemes in particular generally try to solve more than just a flooding issue, and that's what we tried to capture. So after consultation, this is what our scheme looked like, and the purple areas here are the flooded areas, so to speak, and this is where we were going to hold our floodplain in Tipperary Wood and using existing parkland to try and hold it back. Now the cross section at this point changed because you'll notice the purple lines no longer flank the river, they're pushed back further. So this is now the typical cross section. You can see we've pulled the flood walls as far back from the river banks as possible. That was for a number of reasons. One, that it helped maintain and keep the historical trees that were along the river, providing shade. It kept our machinery and construction works away from the river. But it also prevented creating a corridor, because if we had boundary walls on the left-hand side and we had a flood wall on the right-hand side, that created a corridor. And generally when you're designing in the public arena, it's undesirable to have those cornered-in corners or narrow corridors for people to walk down, particularly for lone walkers or vulnerable people that may not feel safe. So this solved a number of problems, and we were able to hide the wall on the left-hand side, for example, into the boundary of existing properties, where we took their wall down and we replaced it with a flood wall. We cladded it so it looked like a wall to them, but it was a flood wall nonetheless. So just to address, the main factor here was the environmental consultations and some of the issues that we identified from the outset. We understood that an environmental impact assessment screening was required and an environmental statement was necessary just because of the environment we're working in. We also conducted a HRAS screening, and that included a lot of surveys, including bat surveys and some seasonal surveys, which is why you sometimes get your contract sort of slips out slightly, because some of the ecology surveys are seasonal. We then undertook detailed consultation with the main people who were dealing with it Landwise, and that was River Restoration Centre, Fisheries and the Forestry Service in relation to using Tipperary wood. On top of that, then we also had to consult with statutory bodies as normal, and then we had to complete our environmental statement and publish it. And that really is another step in the consultation ladder. You then have to seek people's opinion on what we've stated, not just the statutory bodies, which is important, but also the public. And for that, we held a public information day in Newcastle. Because of the demographic we're dealing with, and because flood alleviation schemes by their very nature impact on villages and towns, towns and villages are not one type of one people. So what you'll see there, for example, is that perhaps the medium in which you communicate with people has to change. We did already have a website up and running, and we kept that available for people updating them. But we felt that some people either didn't feel comfortable or didn't have the means necessarily to access the internet as much as they wanted to. So for people that were directly impacting, we fell back onto some sort of old-fashioned or more traditional communication methods, and that was both a letter through the letterbox, but also face-to-face consultations where myself and some of my team members went round and knocked on door to door and just explained to people what the concern were. you do have to fully appreciate that engineering work is disruptive to the community. There is a goal we're all trying to get to, and that's to protect these 321 houses. But in order to get there, everyone has to be in it together, and that's why it's important to have some face-to-face consultations at time. We also did the CIWEM Design and Construction Award, and we also developed our registration for environmental actions and commitments, and that fell out of our environmental statement and was passed on to the contractor. So I'm sure we're probably all aware of what's included in the environmental statement, and these were the main topics that we sort of hit upon. Some ones I'll highlight, for example, is the landscape and human health, which we had to ensure that because we were going through a park and a public area, we wanted to make that visual impact as little as possible. So in some cases, we were able to hide our flood defences or disguise them as domestic boundary walls. In other cases, we actually buried them beneath the earth to appear as embankments. The other one then was the drainage and soils, because we were dealing with heavy sands in the area. This was proven challenging both for seepage, because we were concerned if we built a flood wall in the traditional manner with shallow foundations, it would be bypassed by piping failure should the water level rise, and so the wall then use the sand to bypass the foundation. So on the mitigations, then you can see on the right hand side of the screen there, we avoided any in-channel workings in the River Shimna. We identified that basically the Fishing and Angling Club were the stewards of the river, and they had been looking after the river for so long that we couldn't easily work in the river because we had to avoid certain salmonid times. This would extend both our programme and the cost as well, plus potentially delay if we ever missed the window. So therefore we pulled our scheme out of the river completely. We had the construction environmental management plan, which helped sort of capture all the issues we're concerned from an environmental point of view and pass it on to the contractor so we could develop a plan jointly as how we'd address this. Excuse me. The contractor's dust management plan was a big one because although we had told the public there would be substantial disruption to the local road network just purely with trucks and lorries, we didn't want to transport dust or mud off our sites. That was another factor we had to think. The other thing I'll mention here is the invasive species. We had identified knotweed fairly early on in the scheme, and from working in rivers over the years, you'll identify that once you find any sort of knotweed, the knotweed is used the river as a transportation system, so it generally spreads rapidly along river banks. So for that, we had to do some biosecurity for all the plant moving in and out of the area, and we didn't then disturb it. We couldn't probably commit to eradicating it because that would be a much longer term plan, and the council had already started treatment. So what we did is we took the treatment forward, continue the treatment, and then we'll hand it back to the council as we leave. So all that consultation led to this scope of work. So if we look at the main scope of works here, the red lines now are your flood walls. The green areas actually are the embankments where we've buried the wall either under a pathway so people can walk over the top of the flood wall without realising they're walking over it. And the bank on the south of the picture, the bottom end of the picture, that green bank actually is earth embankment that allows tractors, lawnmowers to go across the top of the flood wall without the need for a floodgate. So we had to demolish a number of boundary walls in order to construct our scheme. That was done through agreement with the landowners. We did have to fail a number of trees in the area, some mature ones. That was unfortunately unavoidable. And generally you have to look at both the constructability of the scheme to try and get the scheme constructed, and you have to save as many trees as possible, but some inevitably just have to go, and those are either done for strategic reasons in order to fit machinery in order to get the works done, or the works themselves. You can imagine the sheet pile being driven to the ground will actually cut a number of roots and could make a tree unstable. But in all cases where we move a tree, the Department for Infrastructure are particularly good at this, they'll identify that, and those trees can then be replanted as part of a planting regime for the wider scheme. We relocated the drainage ditch. We've done 14 metres of brick concrete clad wall, and this is where walls are disguised as both being a normal low-lying stone wall or a boundary fence wall, and those are where we try to hide as much of the scheme as possible. Constructing the new pathways, realigning existing pathways, so because we were moving the pathways or digging them up in order to do the work, the pathways we put back were to code to improve access for all users, and then to also hopefully get a bit of improvement by the erection of pickables in the area. So this was the benefits. So the primary goal was achieved, and that was to protect the 312 properties, and that was very important because That's ultimately the goal we set out to do. We also then satisfied a number of other social aspects around the flooding, and that was to improve access through the park. We improved the junction design with the pedestrians by able to install pedestrian handrails. We had a new planting in the public areas and new picnic and table benches. So that shows you that how, if a flood alleviation scheme is designed correctly, it actually has much wider benefits than just the social and economic benefits of preventing flooding. It can reach out in the wider community. And thankfully, I think this is where I pass on to our contractor, Gerard. And just like the usual job, I get to pass all the problems on to Gerard, and then Gerard gets to solve them for me. Does that sum it up, Gerard?
Yeah, I suppose that's about right. Good evening, everybody. My name's Gerard McColgan. I'm a contracts director with Dawson WAM and contracts director for the Shimna Flood Alleviation Scheme. So the guys there have given us a bit of a background into the drivers for the scheme and then the design. So hopefully in this presentation I can try to, suppose, knit all that together and take you through some of the aspects from the construction point of view, particularly around the environmental aspects. So without further ado, so some of the programming and contract constraints. So we were awarded the contract back in September 2021, and we were awarded, appointed as principal contractor. Contract completion was 52 weeks, which would be after the contract start. We mobilised in mid-October last year. Some of the contract constraints, so there's no in-river working permitted between October and February 2022, and as Karol alluded to, there wasn't much of this required anyway, because the vast majority of the work was able to be undertaken outside of the channel. Island parks had to be completed by the end of April 2022, and thankfully this date was actually achieved because it just passed. But there were further benefits of actually starting in this particular area, as this stretch of wall, which is approximately 260 odd metres, by completing it first, it provided protection to the vast majority of the 312 properties that were at risk. So although the scheme is not yet complete, the vast majority of the properties have already actually been protected as a result of us completing that section first. Another constraint was the tree cutting and the shrub removal. Although the vast majority of the tree removal was undertaken prior to a contract award to yourselves, we had some to remove, but as well as that, we actually had extensive scrub to remove in a number of different sections. So that brings it on then to the environmental consultation. I suppose, as previously highlighted by Karol, the River Shimna is a significant salmonid river area, and it's an area of ASSI. We developed a construction environmental plan, and it was developed, and it has and currently is being implemented throughout the construction process. And I suppose we had significant consultation with a number of public bodies and stakeholders, including the NIEA, the Water Management Unit, the Pollution Prevention, the FI Rivers themselves, the Shimna Angling Club, the Fishery Rights, DERA, and the Forestry Service. As Karol highlighted, there's sections that was up through the Tipperary Woods, among others. So we also employed an on-site ecologist who undertook pre-construction ecological surveys prior to scrub removal, and us basically mobilising into all the different sections of the scheme. So just going to move on to some of the technical stuff. So on the left-hand side there of the slide, you can see really it's a typical cross-section of the flood wall in Shimna. So as Karol alluded to, there was piles required onto the flood wall. These were active for two reasons, both to provide stability and to prevent seepage under the wall in a flood condition. So as you can imagine, as the flood water would increase up the wall, the loading on the wall would significantly increase, and therefore increase the likelihood of the wall overturning, and as well as that, increase the likelihood of seepage onto the wall. As the ground conditions within Shimna were very granular ground, predominantly with sands and gravels. So the piles varied in length from about 5 metres to 11.5 metres, depending on the ground conditions. Then we had, on top of the piles, we had a steel capping beam, which in the picture there on your left-hand side you can see, which is fairly standard. You can see the reinforcing bar there coming out of the piles and protruding into that. Then we had a standard reinforced concrete wall placed on top of that, which again you can see it there just being constructed. And again, this was constructed at varying heights throughout the project, depending, I suppose, on finished ground levels and the actual flood level requirement. And on top of that, then you had an anti-climb coping. Just some of the wall finishes as well on the scheme varied. We'll see some of the slides later, but to give you a flavour of it, it really varied from natural stone cladding, brick. Some of them are painted, and some of the walls ended up having a fence on top as well. So we're talking about piling and secant piling. Just to give you some more details on that, I'm not sure if you are all familiar with secant piling. Some of you may or may not, so I think it's worthwhile get into this in a bit of detail, because there are some key benefits and it's a key element of the scheme, although it's an element that's all buried now that nobody can see and probably can't appreciate that it's there. So what are secant piles? Secant pile wall is formed by constructing alternative primary, which are female, and secondary, which are male concrete piles, where the secondary pile partially cuts into each side of the primary in order to form a continuous impervious structure. So suppose if you look at the diagram on the top left-hand side, the light grey piles are the females, are cast first. They are then left to cure, and then the secondary piles, which are the males, are cast. These are the ones shown in the dark grey, and they're partially cut into the females, giving you a solid wall. So the male piles then, as you can see from that diagram as well, have a reinforcement cage put into them. And that reinforcement cage, by the way, is prefabricated off-site and has come and then installed into the wet concrete pile. This technique is also extensively used in basement construction. There are some advantages of sheet piled walls, there's some advantages over sheet pile walls in close proximity to buildings or where dense ground conditions are, where you're in rock. So there's nothing wrong. Sheet pile walls is also extensively used for the same application in flood alleviation schemes. It's equally an effective technique for this purpose. Given the dense ground conditions at Shimna, secant piling was a more appropriate piling method, as sheet piles would have proven difficult to drive, cause large levels of noise and vibration to surrounding properties. So therefore the secant option was well suited to Shimna. Just then, as regards to the formation of these piles, you see on the left-hand picture in the bottom, you see the white polystyrene blocks. These are polystyrene formers, and they're in a trench and they're supported with concrete for accurate installation of the secant pile. So these formers are machined to the exact profile of the secant pile wall design. In this instance, they were 450 millimeters diameter, and they're actually profiled as well with the exact overlap, as you can see in the top diagram. And by the way, the polystyrene is actually removed prior to drilling into these, and it's actually recycled. Otherwise, if you didn't remove it, you would end up having small beads of polystyrene all over the place, and that wouldn't be particularly good, particularly close to a watercourse. So again, just getting into some more details about the secant piling and the cased CFA. Our piling rigs utilise a double auger drive system to install our secant CFA piles. This differs significantly from the conventional continuous flight auger piling technique by utilising an external casing which acts alongside the auger string. The casing is rotated anti-clockwise at speeds of up to 66 revs per minute. Conversely, the auger is rotated clockwise at a similar rate. So just to look into that, the conventional method if you look at the left-hand side, you can see the auger string in the middle. It's just basically like a big drill bit. The conventional method only uses that system, or our system has the case system, which is basically like a tube surrounding, which is shown here in the red. And if you even look at the right-hand side, you can see it in detail. You can see the casing around the outside with a cutting ring on it, and then the auger string in the middle with the teeth on it. So if you want to see some more details in this, you can go to dawsonlam.co.uk. Some of the benefits of the double auger drive and the external casing to the project over the traditional conventional method. A more accurate installation. They're less susceptible to moving offline due to obstruction. So particularly in Shimna, where we encountered a lot of boulders, etc., this method proved its worth, really, because it meant we were able to get through the obstructions and actually stay online. There's actually savings to be had as well in concrete and spoil quantities, as the casing on the outside prevents drawing in additional extra material. So you could end up with basically piles bigger than what you would need them, but with the case system you can alleviate this. And so that's classified as, we use that term called flighting. Case CFA systems have been used by ourselves for over the last 20 years. And again, we have the capabilities of doing piles up to 1,200 diameter of depths up to 38 metres, which is way above and beyond what we're doing here in Shimna. So just there on the right hand side now, you can actually see the piling rig itself. So basically this piling rig was utilised to drill all these piles, of over 3,600 of them to be precise, to complete the 1,430 linear metres of flood wall. So what you have here, the big tube, is really what we talked about in the previous slides about. That's the double auger system, and this mechanism just drives down to the desired depth, and then as it's then extracting, the concrete is popped up through the holes, as you can see there. The concrete is then filled into the void that's left behind as the tube is extracted. It's a vibrationless technique, which reduces the risk of damage to surrounding properties. And again, it's flexible with varying ground conditions. Again, Shimna had very much varying ground conditions. So again, it proved its worth, the second pile system here. You know, if piles are cast, you know, if you encounter rock, which we encountered rock at high levels, we were able to drill down into it and provide a rock socket. Where if we were using sheet piles for this application, we'd have basically, you know, got refusal, and we would have had to cut the piles off at a higher level. So, and again, the zone of influence reduced from the use of second piling from 150 metres from your working area down to 30. And this proved beneficial from an ecological point of view, as I can have some examples of that later. Again, there was a number of services we had across with the flood scheme in Shimna. To name but a few, there was a gas main, and there was an Northern Ireland water trunk main. So again, utilising this method, we were able to pile within 100 millimetres of it, whereas if we were utilising sheet piles here in the ground conditions we're in, we would have been implementing a lot of vibrations onto that surface and potentially run the risk of actually fracturing it. So again, it was beneficial. And again, just sheet piles as well, given everything that's going on in the world in the last 12 months, the procurement period, etc., for steel and sheet piles has extensively increased, and so has the cost, but mind you, so has the cost of concrete obviously as well. Both Alan and Karol had talked about the roughing grill earlier, and I must admit, when we were first given this contract, I was never heard of the term roughing grill before, but I know all about it now. So just to reiterate, back in August 2020, the debris blocked the Tipple Arch Bridge, new bridge, resulting in the flood level rapidly rising and overtopping. So the solution was to install the roughing grill, as the guys had highlighted earlier. So this was upstream of the new bridge up in the Tipperary Woods. So the solution was to put in these 5 tubes, which were 5 number circular hollow section vertical tubes. So again, we encountered rock at a high level, so we come up with a vibrationless installation using our case system to screw the piles into the rock. So again, because the rock is at a high level, traditionally we would have hammered these piles into the ground using, you know, a vibro and then maybe finishing off with an impact hammer. But because we were able to utilize our CFA piling rig to screw these tubes into the ground, which is really the same technique as we use from the second piling slides that I showed you earlier. The only difference here is that we were able to screw the tubes into the ground and detach the tube from the piling rig and remove the auger string from the middle, basically leaving the tubes behind, and that's what you see there in the bottom right hand picture there. So we're left now with the 5 tubes right across the water course, and the idea is these will capture the debris coming down the scheme now, or coming down the river in a flood condition, and rather than it choking up the new bridge's arches and flooding in that position. So you're basically simulating the flood upstream. So some of the advantages of using this technique for putting in these tubes. So the badger set, so I talked about the zone of influence earlier, it's greatly reduced by using secant piling. So the badger set was encountered by the ecologist on a pre-survey, but because of the technique, we were outside, it was outside the zone of influence, so therefore we could let the badgers be, whereas if we had been impact driving these in, we would have had to go and reassess it and potentially program delays, and that happened in a number of sections on the scheme, and because we're using the technique, the secant piling, we avoided having to disturb particularly badgers. So, and as well as that, it's less disruptive to the local community, and most of all to the fish in the actual river. And again, we work very closely with DAERA on this particular one because it was in the river. And in fairness, DAERA gave us, we were highly commended by DAERA at the end of the installation. So some more stuff on the environmental side of things. Again, ecologists undertook the surveys for the species, including the hedgehog, bats, badgers, red squirrels, and otters, among others, prior to the commencement of the construction in each of the areas. They applied for the Section 48 and 14 permits before we were getting to the small sections. We had to get access into the water courses, and again, from a programme perspective, we purposely pushed these further down the programme to give us adequate time to get these applications and liaise with the relevant bodies and get these permits in place, because there was an awful lot of work involved in that and making sure that we were doing everything in accordance with the requirements. The fish rescue was undertaken prior to the river work, so again on the top right hand side there you can see the guys in doing the fish rescue, and even there in the yellow is just an example of some of the fish that we actually removed. Silt curtain was installed in the river. Really then when we removed the fish from a particular area, we put in a silt curtain both upstream and downstream from it, really to prevent the fish from migrating back in to them areas where we removed them while we were undertaking the in-river works. And again, we had the silt fences throughout the whole scheme, right around the perimeter of the river to prevent any runoff from the construction activities from getting into the actual water course. Erected a lot of bat boxes around the scheme. The guys talked earlier about the treatment of the invasive species, and again we just picked up from the council's treatment process, and we just continued that on, and that is ongoing. And again, the guys talked there about too, there's a lot of mature trees removed. We have replanted some trees, and we will be replanting the same quantity, if not more, that was removed to actually deliver the scheme. And noise and vibration monitoring that was ongoing throughout the scheme, particularly during the piling operations. So on to the community engagement. The community engagement, there was a lot of community engagement done by the client and the consultant prior to us coming to the scheme, and we really just picked up the baton from this and took it on. It's beneficial, I suppose, to point out that because we were coming and these people had been flooded out, on a number of occasions previously. They were basically welcoming you with open arms. Well, to the degree until they saw the size of equipment that we were going to use, and then they had maybe a different approach. But anyway, we had open evenings prior to commencement of the scheme. We produced 3D SketchUps, which were key because you can see one example there down in the bottom right of the slide, and now that's just showing our compound. But we even produced these because down along the Shimna Mile, we were in very close proximity to people, the back of people's houses, and we really took away their gardens to actually build this wall. So by producing the 3D SketchUp, we were able to really simulate the size of the equipment we're going to use, how close we'll be to the residents' houses, and at least then whenever we came along to do the work, there was really no surprises. So it just made the whole thing go a lot smoother. And again, we had a lot of integration with the local Shimna integrated school came down for their geography class. We had Queen students down for the shadowing experience there in April, and Adam McColgan there, the site agent, he had run a charity event there for Autism Initiatives NI, who we were in very close proximity to while undertaking the works in the Tullybrannigan River, and we were thankfully able to run a successful charity event. And we were able to raise over £3,500 for them, and they were delighted for that. We were delighted to be able to give something back for them because they worked very closely with us. And then we even get the odd resident making us some tea there, as you can see, out in their own back garden. So we must have did something right. Just an update then on the actual progress of the scheme. So with 2 sections of the scheme complete. So if you remember back to Karen's slide earlier, the section really is divided up into 4. So we have 2 of them sections to complete, one of them being in the Island Park. And you can see that there in the bottom left-hand side. And I think if you remember back to some of Karen's slides, and he talked about the design, and you can appreciate the Shimna River is actually running parallel here to the footpath in the bottom left-hand slide, just in behind them trees. If the initial design, had to run really the wall right along the banks of the river, moved all them trees, the fish wouldn't have the same screening as they do now. And I just think the way that they have designed this scheme and set the wall back where they could, of course, wasn't possible everywhere. It really adds to it, and it kind of blends into the whole surrounding area and doesn't look as intrusive. So again, if any user is ever down in the Newcastle area, I think you should have a look at that and compliment the designers for that, because I think it certainly blends in very well, and it certainly made construction a little bit easier. We're currently on programme, as Alan had alluded to earlier. We're probably at 65% of the way through the scheme. We've all the piling works now complete, thankfully, and we're due to be complete in September this year on programme. So hopefully you found some of that interesting. Again, I just really scribbled over the top of a lot of the stuff. There's obviously a lot more detail in that, but hopefully you found it interesting, and I suppose we're happy to have any questions that any of you may have.
Okay, thanks very much, gents. That was a really fantastic presentation. So as Gerard says, we'll move on to the Q&A part of the session. And can I just remind all the attendees that if you want to ask a question, there is a question box on the panel there. So we've got a few questions there, but I'm sure there's a lot more questions that people want to ask. So make sure you get your question put in there, and we'll try to get to it in the next 10 minutes. So I'll kick off here. We've got one question here, and that is, what was the form of contract used and why?
The form of contract was an NEC price activity schedule, option A. That was, we did develop the type of contract and selection of contract. We're working with the Central Finance Directive, or CPD, basically, and they advise us on which type of contract would be best. And we also then work with the market in a wider scheme, because I think most contractors feed back to CPD and what the market looks like at the moment. And we found we could break the work into measurable pieces, let the contractor develop an activity schedule to improve his cash flow, and then hopefully that would allow both parties to achieve a scheme relatively quickly, and for the contractors to get paid relatively quickly.
Okay, super, Karol. Next question is, what was the extent of future-proofing included given climate change trends?
Yeah, so climate change is something that you have to be acutely aware of in all schemes, particularly in flood alleviation schemes. And for that, what we did was that we looked at how the predictions are for climate change in the future with rainfall intensity and storms intensity. And we include for an element called freeboard, and that's where you calculate what the flood level would be, and then you add freeboard to both take inaccuracies in model, potential blockages, and climate change the whole way up. But we also, because we had a model, we did some hydraulic calculations on what the catchment could look like in the future with increased urbanisation and that, to try and future-proof as much as possible the scheme, and wherever possible we can, we always design for what the unknowns are largely regard climate change, but there's substantial freeboard on all these schemes and all flood alleviation schemes throughout Northern Ireland.
Okay, super. Another question here. Was there a situation within the scheme where a service location led to a bridging of services, creating a break in the flood wall or defence? And if yes, how did you deal with the risk of preferential flow paths through the service bridge?
Yeah, so piping or bridge failure is common in flood alleviation schemes and something we try to avoid wherever possible. Gerard did allude to both Phoenix Gas and also NI Water. So wherever you have water mains passing beneath or through a flood alleviation scheme, you generally pile as close as you can. I know I'm making this sound very simple, Gerard, as a consultant, but you pile as close as you can either side, and then you construct a wall above it as close to the top of the service you can, and the bottom of the service you inspect the ground to see if it's reasonably cohesive and it's not going to pass through too much water. At the end of the day, the time between the flood water being up at the full hydraulic head and going down is it's a fairly small window, not sufficient to get a lot of water passing through very small openings. Would that be fair enough to say, Gerard? That was very simplistic.
Yeah, that is it. You've hit the nail on the head there. And again, this back piling technique that we utilise, because if you think there back to some of my slides in the polished iron former, so what we actually did was we dug down and exposed the surfaces first and got the exact location of them. And then from that, then we were able to strategically place the actual polished iron formers so that they were as close to the surface as we felt we were comfortable. In this instance, we were 100 millimetres. We actually provided some protection to the side of the actual surface so that when we were piling, if there was any stones or anything, it didn't push it actually into the surface. And then when we piled it, then we were able to excavate down, because some of the surfaces were actually quite deep when we were past them, so we were able to dig down to them and bridge across the top of the structure between the piles we'd installed either side, and then complete the flood wall above that right up into the captain beam. So, yeah.
Okay, very good. Another question here: what issues have you experienced on site in relation to environmental mitigation, and if any, did the SEMP equip you to deal with this?
Well, I suppose probably from the outset, from the very start of this, because we'd done an environmental statement, we had a lot of the environmental statutory consultations already aware of the scheme, and some of them actually have been out and visited, and so we were able to develop a construction environmental management plan, which then we passed on to Gerard. And I think from our perspective in the design, we tried to address the majority of the concerns in the design, and then we were able to give assurances that we addressed by the contractor. And Gerard, I suppose over to you now, what you did on site.
Yeah, the key with all this is consultation from an early stage, and obviously the client and the consultant had done this, and I suppose whenever we arrived on site, the scheme wasn't a surprise to any of the key stakeholders, and therefore that to a degree made it easier because they had bought into the scheme. Now, but furthermore on that, we had undertaken additional consultation with these key stakeholders, and any of the concerns that they had had, we then implemented it then into the environmental management plan, which was key. But furthermore, you have to appreciate we would have nearly fortnightly visits from a lot of these key stakeholders to the site, and Adam, who's the site manager, would have a very good relationship with these, purely because he would have been liaising with them from the start, and in every phase of the scheme he would invite them out to really monitor the works and make sure that it's done in accordance with them. So I think the key thing is communication from an early stage, and keeping that communication going through the construction process has been absolutely key.
And I think we were quite fortunate in this scheme, because I presume Alan will probably back me up here, but DFI Rivers work hand in hand with probably Mother Nature more than most departments, because a lot of their works are dealing with rivers and Mother Nature on a daily basis, and they're probably fairly well switched on. They even have an environmental department, is that correct, Alan?
Yes, Carl, if you can hear me, that's right. Yeah, it's like, as you say, all our schemes are very environmentally sensitive, and we would have an environmental scoping exercise carried out on all that to see whether actually needed a full environmental statement or not. And even, although we did need one here for obvious reasons, but even on schemes where there wasn't a statement, we would still get the consultant to consider a lot of environmental mitigation, in some case enhancement methods, so that we leave the wider area in a better state than what it was before. Okay.
Okay, that probably ties in quite well with the next question. And what was the most effective mode of community consultation, and how did you show the community you took their views into account? I suppose what you say is face-to-face, knocking on doors and talking to people directly.
It does. I think it's basically, it's based upon as horses for courses. Basically, if you're directly impacting someone's property, we are always very keen to do face-to-face consultations, because that you're impacting on someone's home, you know, and you do need to go out there and meet those people. Whereas the wider community, you still might need face-to-face drop-in centres, as we call them, or that there, and then the wider community again is just keeping them informed on that. But we found it very much depends on what the impact is on that resident and how you talk to them, whether it's going to be face-to-face, internet, or letter drops.
Yes,
yeah, just Robert.
Touch, yeah.
Sorry, I was just going to say quickly there, Robert, and as I said earlier on, like, as part of the detailed design card, getting involved with detailed lands agreements at an early stage. Some of those were back and forth for 2 years before we actually even got anywhere near the site. And it's all about, as Gerard, I think, is going to say, bringing people along earlier with you, you know, so that they feel part of the scheme and understand the reasons and the benefits of it.
Yeah, the key thing for me personally on the scheme was probably not really understanding fully the background and the driver to the scheme at the time we got awarded it. But when we had our open evenings and just talking to the people face to face, particularly the people that have been affected to this, even back to 2019, and some of them residents hadn't even been back in their property since that, and you could see even the distress on their face. And I alluded to it earlier, they were delighted to see us coming along to build this scheme to really protect their houses so they could get insurance and actually sleep in their beds at night. So, I think from that, it's not normal you get that in a construction project, you know what I mean? Because most people don't want to see us coming because we're digging up holes and people don't see the benefit. But this was unique. But again, that engagement then really took off from that, and the residents, we have a very close relationship with them. And again, I alluded there back to the picture earlier with one of the residents making us tea in our back garden and baking us cake. So that kind of shows you the level of engagement and relationship that our site team have. I have a very strong site team led by Alan McColgan in this scheme, and he has really built up a good relationship with these residents, including the stakeholders, and that coupled with the client and the designer and the consultant has been key in driving the scheme to where it is today.
Very good. I think we'll take a couple more questions and then wrap it up. There's maybe a couple of questions that can tie together. So first off, was there any value engineering applied under the contract, and were there any situations where the existing structures could be utilised as part of the flood defence?
Yeah, so generally, value engineering always takes part in the majority of schemes, either by desire or want or just necessity, sometimes by garden budgets. So the value engineering was always about de-risking wherever possible. So once the contractor's appointed, generally consultants, and particularly in this scheme, we all sat down and just seen how we could value engineer some elements to make it either more economical or save money for the central government. In regards to utilising the existing structures, some cases it's a very hard call to make, because in order to do the full analysis of a ski of a structure to see will it hold up for the forces and that, it does take a lot of analysis, and then sometimes you have to end up knocking down something to analyze it just to draw a line under it. We did utilise the new bridge now, because we tied in either side of it. After the full structural inspection of it and seeing what condition it was in, we then tied into that. So it very much is a moving feast. So once you get appointed with the contractor, I suppose you do have to sit down and work as a team to value engineering. I don't think value engineering can be done by one party in isolation, because it just doesn't work that way.
Okay, that's great, Karol, thanks. We'll take one last question here, and that'll be, what mitigation was required for mammals such as hedgehogs?
So there was a number of mitigations regarding for a lot of, quite a few actually, from hedgehogs, badgers, bats. So for example, for the trees, we had to conduct any sort of surveys to ensure there was no roostings in places, take trees down. For the badgers, we actually tweaked the line of the wall away from certain things. Wherever we identified potential halts or dens, or for otters, for example, we had to erect a CCTV camera. I'm sure it's not called a CCTV camera, but that's what it is in my mind. And it had to then record to ensure that it was dormant. So I think Gerard pointed out that we had an ecologist appointed who was able to work with us on site, because you're never going to capture all the mammals on the surveys. You're only going to capture them once you start working. And I think our ecologist was pretty much kept busy for the first few months of the scheme. Gerard, would that be fair to say?
Yeah, because we were obviously very keen to get in and get the scheme going as quickly as possible on as many fronts as possible, given the other restrictions. So thankfully our ecologist was very helpful and beneficial in that manner. And again, there was occasions where we had even encountered badger sets and stuff, and we did have to set up CCTV. And there were other instances where there was actually potential evidence of hedgehogs, and we actually had to set up, correct the terminology, but they were like wee triangular holes with paper in them and actually dye in them, so you could, and then they were all disguised under some old branches and stuff, because that apparently is where you would see hedgehogs and all travelling through. So that's the kind of levels and extent that our ecologists went to in the scheme to make sure they were clear from any species prior to us actually going into the different areas. So I certainly learned a lot on this scheme about different species and the way they work. So yeah, the ecologist was key in all that.
Okay, thanks guys. So I think we'll bring it to a close there. I'm sure everyone will agree it was really informative and fascinating presentation and a stimulating Q&A session. So thank you again to the panelists, Gerard, Karol and Allan, for all the work they've put in there today. Thank you to our friends at APM for hosting tonight's webinar. We at CIWEM have only really started collaborating with APM last year, so it was great to have them back again this year, and hopefully we'll get many more joint events in the years ahead. And finally, thank you to everybody who tuned in tonight. It was a really good turnout. I think there was about 75 at the peak, so really good to see a big turnout. And if you're speaking to any of your friends or colleagues who were unable to attend tonight's event, it'll be uploaded on the APM website and YouTube channel for later viewing. So thank you all and enjoy the rest of your evening. Goodbye.
Thank you.